have more details about this. Okay, well, now I suggest that we proceed with our presentations. We have now Horia Petran from URBAN-INCERC, who is going to give a presentation about the progress needed on ventilation and airtightness in Romania. And well, now, Horia, you have the floor.
Thank you very much. Hello, everybody, and thank you for staying with us. Try to make a very condensed presentation on what I imagine as priority in the necessary progress on airtightness and ventilation in Romania. And the content of my presentation will focus on 4 major issues: the airtightness of the building stock in Romania, the potential impact on ventilation on energy performance of buildings, numbers on Romania, the envelope permeability, what are the indicators for quantitative and qualitative evaluation, and testing methods and current investigations used. The second one, ventilation use issues in rehabilitation program. So in the activity of improving energy performance of existing buildings, the context and the schemes used for national thermal rehabilitation program, the key actors involved and their influence, and the impact on air quality. The ventilation of low energy buildings and nearly zero energy buildings, as you may know already, it's very important. I will try to emphasize some requirements and weight of ventilation in energy balance compared to the current practice of our existing buildings. And what are the solutions we can imagine for this kind of buildings? Last but not least, indoor air quality in educational buildings, which is a very important issue. What are the requirements for this kind of buildings and the practicalities? Which is the current situation, and what are the challenges, equally for energy efficiency and for indoor environment? First of all, in order to evaluate the potential impact of ventilation on energy performance of buildings, one should take a global look at the numbers related to the building stock on Romania. According to the Romanian National Commission for the Statistics, a total of approximately 8 million housing units exist in Romania, serving a population of more than 22 million people. The total residential buildings is around 5 million, with a total useful area of more than 450 million square meters. Of the 8 million housing units, 1 million are situated in around 84,000 block of flats, which consist in 70% of the building stock, primarily located in urban areas. Thin building blocks make up, as I said, 70%. These figures evince the great impact of retrofitting buildings in order to reduce energy consumption. The non-residential building stock consists in more than 230,000 buildings, serving more than 70 million square meters. The energy performance of the building stock varies between 100 and 300 kilowatt hour per square meters and year, depending on the building type and climatic conditions. What is necessary to be said is that Romania has 4 very different climatic zones, with extreme desired temperature for winter between -12 and -21 degrees Celsius, and with yearly average external temperature between 3.6 and almost 12 degrees Celsius. Analysis of urban buildings and their energy efficiency performed with the strategy of Bucharest focused on the more 8,000 dwellings plus non-residential units. that the global energy consumption for space heat only is around 8 terawatt hours per year. Taking into account the usual ventilation in the energy consumption for heating, we can estimate that more than 2 terawatt hour per year in Bucharest only can be of a major interest. Most room buildings do not have mechanical ventilation. The infiltration, we can say, it's the dominant source of ventilation for dwellings in Romania, for the builder. With the exception of very limited kitchen or bath exhaust system, most buildings in Romania do not have mechanical ventilation, as I said, and therefore they rely on infiltration. The leakage and the natural ventilation, the window opening, in order to maintain acceptable indoor air quality. While average, if we're talking about long periods of time and building stock, with existing windows, the requirements of fresh air can be met. The uncontrolled infiltration lead to a very high energy consumption and sometimes to thermal discomfort due to cold drafts. On the other hand, for buildings with airtight windows, the indoor air quality is not ensured by envelope infiltration many times, with bad consequences on moisture condensation in thermal bridges, causing the formation of molds, which affect the health of occupation and building materials as well. About the envelope permeability, this is usually expressed by indicators like air permeability of building components, an index normalized to joint length at 50 Pascal pressure difference, or at building level, it's an index showing the permeability reported to the envelope area, also at 50 Pascals, or reported at conditional volume, the air changes per hour. There are many more or less standardized testing methods and investigations used for assessing the permeability of tightness of building envelope. The most well-known is the blow dot test, the fan pressurization method. Also thermal imaging, the thermography is used as a qualitative investigation to detect air leaks. There are also various ventilation system functionality surveys and also surveys on indoor climate. The door test is sometimes limited to the costs of implementation and relevance of the results. If we're talking about condominiums, about collective buildings, where the air exchange of the apartment with the external environment is made by the staircase, which is a common vault to the building, shall we do the whole building testing, or shall we find representative apartment testing, which is an apartment test, a represented apartment for testing, and so on. Test performed 79 windows in the laboratory for thermal protection of buildings within INCERC, showed a large variation of air index, limited to less than 1.5 cubic meters per hour and a meter of joint length at 50 Pascals. The average is around 0.50, and the results are characteristic for the current insulating windows market, not for the existing building stock. Other tests performed on this time the whole living units, one individual house and 5 apartments, in strategy testing strategy, showed that the following characteristic related to windows. It's 95 to 27 cubic meters per hour and meter at 50 Pascals, and for envelope 5 to 7, and in one case, which is apartment very small, 12 changes per hour at 50 pascals, and the index from the envelope 3 to 7 cubic meters per hour and square meters at 50 pascals. Is more or less the performance of existing building stock, but one question is arising: what is the relevance of values at 50 pascals? More or less, Remi showed us the rule of thumb, but still the question remained why the values are on 50 pascal when the usual conditions of indoor. When I was before, it was related to the relevance of the values determined 50 pascals. And the question was arising about this relevance because visual conditions for indoor air quality and energy performance assessments are around 4 or a little bit more pascals as usual conditions. For the relation issues in the thermal rehabilitation program, as a context, the overall need to increase energy efficiency in Romania as well as in Eastern European housing, which in Romania is, as building stock for housing, is more than 95% private ownership, 95%. It's a broadly recognized fact. Although for solving this issue exist, they are, however, often executed in chaotic and unregulated ways. However, starting in 2002, an ambitious national retrofitting program, target energy performance of buildings, was launched in Romania, which was supported until now by the general state and regional subsidies. More than 85 subsidies of the rehabilitation works and 100% of the energy audit and design activity are financed by the state. However, the priority is given to improve thermal insulation, while the indoor environment with regard to comfort, health, accessibility, safety, and so on. But primarily, indoor air quality, it's somehow neglected by not providing any subsidies for that. Major key actors involved in the rehabilitation process should be aware and trained about the importance of ventilation issues and risk, and also about the impact of bad ventilation on indoor environment quality. I have confirmed in many cases the indoor air quality was lowered while the thermal insulation and air tightness were improved. With increasing concern about energy consumption and conservation, building envelopes are becoming more airtight and consequently contributing to an inadequate environment. Actually, the need for natural ventilation is not taken into consideration when increasing the airtightness of the building. And now, I'm afraid, serious problem had surfaced concerning the indoor environment and air quality. Those problems are increased by the behavior of the occupants to cut down the heating cost. They are using the alternative fuel, even open flame heating source, including the cooking machine, which increase the moisture condensation and the concentration of harmful gases, CO and CO2. The additional emission for the surface materials like furniture, finishings, in the context of irregular or no ventilation of occupied living space, causes the increased incidence of the sick building syndrome. From the crude reality to the far bright future, as building very low energy buildings, very efficient buildings, passive buildings, and nearly zero energy buildings. What is very important to emphasize, and it was also emphasized before, these would have a very envelope. They should ensure a controlled ventilation, especially in highly airtight buildings, the airtightness of that ductwork to be ensured by appropriate technologies and skilled installers also. The heat recovery efficiency should be more than 8%, and this is a must. Aspect of these buildings is related to the weight of ventilation in the final energy use of the building. If, for example, for a typical existing residential buildings, weight of ventilation in the energy use is in the range of 15, maybe 30%. For very low energy building, this can be more of 50%, which increase the need to properly solve the energy efficiency in ventilation systems. Progress is needed to move towards efficient solutions. Most impact can be achieved with the implementation of intelligent envelopes. When I say intelligent envelopes, I mean adaptive envelopes. Ventilated envelopes, internal or external ventilated, with the use of ventilation air. Ventilation coupled with active or passive solar design, and use of night ventilation. Some of the solutions were analyzed by the research team of energy performance of sustainable buildings within INCERC in national programs, and will be briefly detailed as the ventilated envelope, the solar ventilated space, the use of night ventilation. So just pointing out some efficient solutions. First of all, it's a ventilated envelope system. It's a concept of wall with parietal dynamic effect on the exhausted air from the occupied spaces. The functional principle is quite simple. In the winter and during the night in summer, the air to be evacuated from the occupied spaces is circulated by the air gap, which is formed within the wall by applying a very common low resistance layer like a gypsum board. During the night in summer, the external cold air from the outside is intensively circulated through the air gap, providing in this way a cooling surface to the conditioned area. In fact, the variable envelope thermal resistance, which is very high in winter and very low during summer nights. So this is what I said about the active envelopes. Another solution is a ventilated solar space, which is applied in the experimental house within INCERC and was studied there some years ago, which is used for preheating ventilation air during the heating season, mainly. Another solution should be the use of active or passive ventilated facade, as well as for new buildings and for refurbishment solutions. One idea is to use the PV panels as active covering and preheating the fresh air while cooling the elements of photovoltaics. Other solution should be the use of so-called passivation solutions to increase the energy performance of a building and simultaneously use the night ventilation in summer. Night ventilation can be used for cooling passive and active elements like building mass, like activated building systems, use of phase change materials. If you're looking at the graph below, this is presenting a thermal response of a top floor apartment, southwest oriented, in the typical day of July in Bucharest, taken from the reference year. Compared to the 32-33 degree real situation, the application of very simple passive solutions and with a proper ventilation strategy can lead to acceptable comfort without cooling energy. This test include also the PCM effect. Moving forward to a very delicate aspect, which is ensuring indoor environment in education buildings. What is to say is that ventilation practice for occupied spaces in this kind of schools or public buildings differ from those for residential buildings. Studies in indoor air quality, ventilation, and building-related health systems in schools has shown that the ventilation is not adequate in many classrooms and was considered to the main cause of health symptoms. Moreover, other research show that poor indoor air quality in schools can cause a reduction in the students' performance, whereas good quality in classrooms can enhance children's concentration and also teachers' productivity. Therefore, the ventilation requirements are focused on minimum airflow per person, and ventilation needs are in reality much higher because of people concentrated in closed spaces over extended periods of time, and the ventilation rate has to be assessed for adaptation to the dynamic occupation. So there is a need for intelligent ventilation system and for energy efficiency, and in this respect there is a need for low ventilation for long breaks for holidays. Theoretical and experimental studies focused in Romanian schools show that direct and natural ventilation is not effective for adequate indoor air quality. Concerning the major rehabilitation program for schools, which is undergoing for some years, the result is not in favor of indoor environment. With increased airtightness obtained by the refurbishment and no control ventilation, the indoor environment is severely affected. As I said, the correct approach to estimate the requirements for an effective ventilation rate is to check the evolution of indoor concentration of certain pollutants, in this case the CO2 and humidity. For a typical classroom, as you can see, with typical occupancy, the number of air changes required is around 4 changes per hour during the occupancy peak. The evaluation of energy performance of buildings within the energy performance certification schemes offers another issue to discuss because it denotes in many cases an error in considering the ventilation strategy to be used in educational buildings. If no ventilation, no mechanical ventilation system exists in the buildings, then the value for residential spaces is used usually the one for residential spaces in the energy performance certification issuing, which can artificially improve, let's say improve, the energy performance of the certified building, while in reality the indoor air quality is not acceptable. In this case, a correct evaluation is to be done by considering the minimum ventilation rate for occupancy hours and in the long breaks, low ventilation rate, while providing a penalty value in the rated energy value for the inadequate ventilation system. The challenges for this kind of buildings, basically the main challenges for ensuring a high quality environment in educational buildings are for energy performance evaluation to detail and clarify existing regulation on ventilation and energy performance certification, which is not very clear right now. And for the key actors involved, for the architects, engineers, designers, energy auditors, inspectors, and all technicians, to ensure the needed qualification level and proper knowledge on ventilation impacts. If we're talking about government, the Ministry of Education, the local authorities who are managing the rehabilitation program for schools, the inspectors, the teachers is needed raising awareness which can, in this case of educational buildings, its particular case, can generate further impact on education. Last but not least, one of the key actors are the building workforce. It need to ensure the necessary skills. And just to mention, the Building Workforce Initiative from European Commission, call for build-up skills, which is undergoing now, and we hope that we will have a national project on that for build-up skills for the workforce in buildings. For both main objectives, energy efficiency and high-quality indoor environment, it is necessary to ensure tailored technical solutions in order to monitor air quality in the classrooms, in order to comfortable indoor environment, thermal and physiological, but also acoustic, safe, healthy, to implement intelligent control strategy and system based on prediction correction. This presents assist for ensuring thermal and physiological comfort by mixed radiation, convection, offering a good ventilation rate, offering reduced thermal gradient, no drafts and low air velocities, and being a low exergy system is basically an efficient one. In conclusion, there is a significant potential for ventilation in order to improve indoor environment quality in Romania and also to reduce the energy use in the existing building stock. We cannot speak only about only one identified problem with only one potential solution. From the envelope permeability point of view, there are two main issues. The uncontrolled infiltration lead to a low energy performance of building, and the combination between air and between an airtight envelope, irregular or no ventilation, and also the occupant behavior may lead to the sick building syndrome. For low energy or the zero energy buildings, the combination of ensuring correct ventilation and use of adaptive envelope solutions, including connectivity with HVAC systems, these are the solutions that should be sought. Within the existing and future rehabilitation schemes, the indoor air quality has to be a high priority, which is not now, together with other aspects like stability, energy efficiency, safety, functionality, acoustics, and so on. Well, strategy of build it right, ventilate right apparently has many meanings, very different meanings depending on the context, but basically it's a sound starting point and all approaches should be based on this concept. Indoor air quality obtained using the right ventilation strategy and using proper systems. Ensure the right ventilation in schools is of utmost importance. It is very important to identify when is needed with low energy systems in order to obtain energy performance, high energy performance, and should be done with systems which ensure ventilation efficiency and indoor comfort, for example, by mixed radiative and convective heat transfer. For net zero, nearly zero energy buildings, the solution package contains efficient heat recovery, balancing, passive strategies, or activation strategies, using of night ventilation, free cooling, use of materials, renewable sources, and so on. So thank you very much for your attention, and I hope that it has been a content presentation. And if you have any questions, I will be glad to answer. Thank you.
Well, thank you very